Blue Dolphin here, and in this video we're going to be using various disk management tools to manage our disks in Linux. Let's get into it. Alright, jumping right into things and starting off, our introduction into disk management tools reads, in this module we'll be provided the instructions and devices needed to develop our hands-on skills with disk management, file systems, free disk space, and monitoring free disks. Awesome. Alright, let's go ahead and look at our learning outcomes. In this module, we'll complete the following exercise. Exercise 1, using various disk management tools. And after completing this lab, we'll be able to view file systems with lsblk, view the content of a block device with blkid, and use disk partitioning tools fdisk and parted, and then monitor free disk space and inodes using various commands and utilities. Alright, exam objectives. Create partitions and file systems. Given a scenario, manage a storage in a Linux environment. Awesome. Okay, lab duration is usually sometimes right, sometimes not. And let's take a look at our topology. So we have a CentOS server and a Ubuntu server, nothing's changed. Let's go ahead and fire these up. Boom, boom. And okay, so let's look at task 2. I guess there's no task 1. So the lsblk command displays the information about the storage blocks. In the output of this command, the following information is listed. Total size of the partition, total size of the block, and the mount points if any are available. However, the lsblk command does not provide any information on the used or free disk space. Cool. All right, so on the desktop, step 1, let's open a terminal. And it looks like they want us to just try using the command lsblk, and then they want us to try using a couple flags, including A and B and D. All right. So the reason they want us to use the lsblk command A is because it doesn't include empty devices in the list, but we can list empty devices as well with tac A. All right, let's open a terminal. Let's open a termi. And we'll go lsblk. Cool, so you can see we have our SDA 1 and our SDB 1 and 2. All right, cool. So let's look at empty devices and go lsblk-A. I don't think anything really changed. I don't see, oh, I do see something new. I see a loop 8. It's a mount point. Interesting. Okay, great. Let's go ahead and list the device size in bytes by doing lsblk tac D or B. All right, it's clear. Now let's go lsblk-D, and this is going to list only the main devices and skip slave device. So you can list, interesting. Oh, so it's just showing us the main devices. Okay, interesting. So if we don't do that, then we see the slave devices. I see, so we have SDA and SDB, and the slaves SD1, so like the partitions. Okay, so it's just showing us the disks, saying, hey, these are the disks, not the partitions. Cool. I like that. What does that stand for? I'm curious. Let's go lsblk tac help. Just says don't print slaves or holders. Node EPS. Node EPS. Node EPS. Node EPS. Node EPS. All right. Step 6 of our practice lab. Using the lsblk command, you can also display the information about the device owner group and mode. So let's do that. Lsblk tac M. Oh, wow. So I guess the B stands for block, and then looks like user has read and write. Group has read write, and others have nada. Okay, cool. Okay, so next, instead of displaying all columns, we can choose to display only the selected columns. Probably gonna never use that in the real world, but let's try it. lsbo name size. Oh, actually, that's pretty cool. I think I will use that. I think that could be really handy, especially if you have like a large infrastructure to go through and you just want to see the basics. or you don't want to have to scan your eyes left to right and accidentally get the wrong line. That's kind of cool. All right, task 3. View the content of block device. Using the blkid command, you can view the attributes of the block device. All right, let's do man blkid. Learn a little about this new command. And it says so the name is blkid, and it stands for locate print block device attributes. And the description reads, the blkid program is the command line interface working with the lsblk library. It can determine the type of content, FS or swap, that a block device holds. Attribute types. All right, cool. Let's just try it out. Let's go sudo blkid. Enter our handy dandy password. And we have squash file systems. And then we have ext4 disks and partitions with our UID. That's kind of cool. Okay, step 2, press enter. You can use the I parameter to display the IO limits. Cool, let's do that. Sudo blkid -I for show me the IO parameters on dev, in particular dev sdb1. See some magic here. All right, minimum IO size 4,000, physical sector size 4,000, logical sector size 5,000. That's kind of cool. That is neat. And I'm curious, what's the difference between the physical and the logical So it says, modern hard drives have two sector sizes, the physical sector size and the logical one. The physical is what it actually reads and writes. The logical is what you can ask it to read or write. It's not very helpful. Unless that's like supposed to be the swap. All right, let's see what this says. Okay, so don't need to know the math. Okay, too much. What is the point of hard... What are physical and logical drive? Let's see what this forum says. So okay. So older server applications, storage spaces use 512 byte sectors for virtual disks unless there are 4K native disks in the pool when you create it. However, you can add a 4K to a 512. Not very helpful. So is it just like a oh, here we go. Let's look at the old wiki. Disk sector. Okay. So we know a sector is a subdivision of a track on a magnetic disk or optical disk. Yep, sounds good. So traditionally 512 bytes for a hard disk drive and 2K for CDs, and HDs are 4K. It says here HDs are, so traditionally 512. Okay, so I think it's just like a newer format. I think we have like the older and the newer. So some applications might need that older, like that physical versus the logical. I don't know though. Sectors versus blocks. So we don't care about history. So we have physical, okay, logical sector. So logical sectors, the physical sector and the logical. All right, so I feel like it's maybe just like that's where the instructions sit, like how the processor will have like, you know, the instruction pointer and then actually executing instructions on the stack. So maybe this is like the pointer of what's to come next to be put on the stack for execution. That's what I'm kind of thinking right now. Do some research later. Let's move on. You can use the P parameter. Sorry, step 3. We can use the P parameter to display additional information on a specific block device. Type the following command. All right. We'll get some extra information, I guess. They didn't say what. So we'll do -dev-sdb1. Okay. We definitely got some extra information here. So what I'm seeing is that we have our partition is ext4, it's a file system, has a UID, an entry type, entry number. Basically, have no idea what any of that is. Okay, cool. Don't know what the last bits and pieces are. Step 4. Let's use the blkid command to display the file system type in the mount points. Cool. So let's clear this terminal. Let's go sudo blkid-o list. Oh, that's handy. I like this a lot. The mount point. Look at that. Cool. I think we saw that in one of our earlier commands. Maybe not. Okay, task 4. Use disk partitioning tools. Fdis parted. Disk partitioning is an essential part of disk management. When a new disk is installed in a system, it cannot be used in a raw format. You will need to create at least one partition, which then needs to be formatted with a specific file system, such as ext4. In this task, you will learn to use different disk partitioning tools. To do this, perform the following step. Happy to do so. All right, let's clear this and go sudo fdisk-l But you know what? I'm not going to restart the lab. Let's see what happens. What's the worst that happens? So it wants us to play around with parted, not pseudo parted. So again, if you just type parted, just like Fdisk, gives you an interactive prompt. Step 10 wants us to use a whole new command called select. Oh, it's because, no, it wants us to use select within the parted interactive prompt. So we'll go select dev SDB. Now you can see we're using dev SDB. We want to see a little information, so we can do the print command, which I think we can just type P, but it tells us to actually type the word print. That's fine too. They look like the same to me. Very cool. And to delete the partition using parted, we're just going to type RM. And I assume we'll delete. Oh, we're going to delete number 1. All right. Fair enough. And then for step 14, we're just going to say yes to confirm. And we're going to type ignore to ignore this message about being unable to inform the kernel of the change. That's because I think we've deleted the, actually, I don't know why. I think because we made a change and didn't reset. I don't really know. Just my guess. Again, I'm a noob, just trying to learn this stuff alongside with you. So to confirm the deleted partition, type the following print. There we go. Cool. It is definitely, we have 0 partitions. It is just a disk. So we'll hit quit. We get another interactive prompt. And now things are going to get spicy here. We're going to do task 5, monitoring free disk space and inodes using various commands utilities. So if we monitor disk utilization, it's a crucial in system management. The administrator must know a handful of tools to monitor the disk space. In this task, you will learn to monitor free disk space and inodes. To do this, start with the following steps below. Okay, let's monitor free disk space. So we're going to be using the command df, stands for I don't know what, disk free, should be fd free disk. Let's do a man fdf and learn. It is report file system disk space usage. Still not sure what the df is. Df displays the amount of disk space available on a file system containing each file name argument. All right. Very confused about the df. Okay. Let's get started here with df tac A. Wow. It's a lot of information. But you can see here our disks shows us some information here. Very cool. Where it's mounted, use, available, used. Awesome. So you can see we've used SDB 1%, SDA 24%. That's kind of cool. All right, step 2 says we can find the free disk space in kilobytes, megabytes, and gigabytes by doing H. So disk free dash H. And this is probably stands for human readable or something. But we can see here, yeah, size, used, available. It's a little easier instead of these long numbers. Let's see, it probably stands for human readable. Let's just confirm. Yeah, human readable H. Okay, very cool. Step 3, they want us to obviously clear the terminal and find free disk space usage with the file system. So we're going to use df-t. What does that do? Let's go man df. I want to know what the t does before we use it. Okay, it does print type, print file system type. Oh, okay, cool. So with df tab, so it's going to say ext4, ext3, xfs, squash fs, I think. Yeah. So you can see here type, we have our ext4, temp, or file system, squash file systems. Cool, okay, I'm liking this. Step 4, we're going to show this free and use nodes. So we'll go df tac I. Neat, look at that. It's kind of cool. That's kind of handy. All right, step 5. So now we're going to use the stat command to display inode data in file directory. All right, what are inodes? I'm a little confused here. Let's pull it up. Okay, so let's clarify. Inodes, index node, data structure, Unix file system, describes file system objects or files and directories. An inode stores attributes, disk block location, data. So I think an inode is above the disk. It's I don't know, how does it make sense? Everything. What's this? Inode table. So we have our descriptors, our table, and our inode. Okay, so I think the inode is just the structure. Yeah, it's just the data structure. So an inode number index is a table of inodes in a known location on a device. I see. So that's how the kernel file system driver access inode content. Confined locations. Okay. Still don't really understand it, but that's why I'm doing this course to learn. So let's do stat etc. You can see here we have, I don't even know what we have. Device access modify change birth. What? Okay, none of this looks very helpful. So step 6, you can also display the node of a single file. All right, let's go. Stat, tac, format equals %i. Probably never going to remember this. Etsy hosts. Just some number. Okay, so I guess this is the inode identifier. Step 7. We can display the inode of a single or multiple files. All right. To display the inode of a file, type the following command. So lstac il etc hosts. Okay. Still not sure how this is supposed to help me. Step 8. Display inode of multiple files in Etsy directory. I think I need to go do some of the coursework on inodes and just learn a little more about them. Okay, so it's just showing us the inodes. So I think this is just like the identifier, like the number that the kernel would reference to say, hey, where's like the shadow file or the SSL directory? It's, oh yeah, this is in, inode A786545. Okay, I think I'm kind of understanding this here. Okay, huzzah, lab assessment. All right, let's do the questions. Which of the following tasks can be performed using disk management tools in Linux? All of them. So we know monitor, free, and use space. We can do with like parted, fdisk, stat. What other commands did we use? Yeah, I think that's really it. We can create partitions again with like parted, fdisk, gdisk. Specifying the type of file system, same thing, remove partitions, same. All right, next question. Which of the following information is displayed using the lsblk command? So I'm going to go ahead and say pretty much all of them. But let's confirm together. Let's go lsblk. So by default, the command tells us the mount point, total size of the partition. Doesn't say the size of the block though, or used in free space. So this is where we'll have to do tac help. Say, hey, I need to, and let's just use grep and type free. So I don't think there's any command for free space. So let's do grep for size. Is there a command that deals with size? Yeah, so it says size of the device. What about block? So list information about block sizes. Yeah, I think it does it all. Let's just confirm. Let's just take a look at the help again and go through it line by line. So again, list block. All right, so we can see the size in bytes. So this is, okay, boom. So we're looking for size of block and partition and used. So format outputs, yeah, so I think that's going to cover, never mind. Okay, FS available, file system available. Oh, so these are the columns. So then why don't we see FS available? I think we have to do that display column. So tac O FS. Just taking a shot in the dark here. Oh, it worked. Okay. So we can definitely see available. Okay, I'm going to submit them all. Oh, I'm wrong. It does not provide any information on the used or free disk space. Oh, the one thing I didn't look at. Well, I thought, because if you look at earlier where we grepped it, it said file system size used. But nothing to do with like free disk space, hey? All right, well, that's silly. So I guess change your answer. So we know it can use total size of block, partition, and the mount points. All right. So which parameter should you use to list empty devices with the lsblk command? Well, let's find out. I mean, I feel like A, it lists everything, but we might have to specify something that's empty. We did this earlier, but I just honestly don't remember the details. We'll have an idea. Let's use grep for the word empty and go tac help, and then quickly grep through everything for the word empty. Okay, well, let's just try. Let's try ls listblock -a. I mean, I don't see anything empty here, so let's go L. Nothing empty. E? Oh, God. This isn't going to go well. Oh, boy. Okay, so... oh, let's look at the help command again. Okay, let's investigate the L and the A. So L is list. Yeah, I'm just going to go with A, list it all. Yes! Okay, which parameter should you use to list the device size in bytes? I think that's L. Use list format option or B for bytes. Yeah, definitely B for bytes. Which parameter will list only the main devices, not the slave devices? Oh boy. Okay. We did that. Obviously, I don't remember, but don't print slaves or holders. D for don't. Don't do it. Don't do it. All right, summary, submit report. Boom, there we go. That was fun. Oh yeah, let's give him 5 stars, 5 stars, 5 stars, 5 stars. Oh, they 5 stars by default. Submit feedback. All right, here we go. Boom, boom. Completed. Okay, awesome. See everyone in the next video, working with kernel, boot modules, and files. Boom, let's get into it.